BSidesSF. So out of the thousands of students that go there, we got one. And he got a job working for OpenDNS. So let me turn this over to you, because I'm curious to see what you got. When did you graduate?
How far back? Can you guys hear me? Okay.
Yeah.
Sorry, I'm just trying to judge the mic beforehand.
Just start talking.
2014?
So last year, an OpenDNS hired you right away, and now you're making $150,000, $200,000 a year.
I was actually hired before I graduated.
Congratulations! So. Talk to them.
Hi. Like Doug said, my name is Kevin Bottomley. I'm one of the security analysts at OpenDNS. I apologize for the spotlight behind my slide deck. You'll just have to bear with me. I'll put it up probably on SlideShare or something immediately following the talk. So my Twitter handle is, you probably can't see it, it's K3V B0T. So if you just follow that or look there, you can find it. So let's move ahead. Actually, Doug ruined this entire slide for me. So, like he said, I graduated from City College in 2014 with an AS in Computer Networking and Information Security. I'm currently a security analyst with OpenDNS, along with half of the crowd, it looks like. And then I've also spoken. I spoke at BSides last year. I also spoke at BSides LA, NASA AIM Security Week, and BSides NYC earlier this year. A little bit about what we're going to go over. Some of the common prominent variants that we've seen in the ransomware department. Some of the vectors of compromise, the C2 setup and design, and kind of how we went about tracking these and stopping them really quickly. So this is kind of a little historical thing. This is your classic FBI lock screen, kind of circa 2002 or 2012 or somewhere in there, 2011, mainly delivered by the Revitin family, Trojan family. It was basically just a fake lock screen that you would see. It would have, sometimes it would tap into your webcam, give you your IP address, tell you that you were doing something illegal. It's super easy to get around. You could just boot into safe mode and use anything like malware bytes or something to remove the registry key and just get rid of it. Not really anything too crazy. But as time went on, we started to see this guy who kind of came on the scene pretty fast, Cryptolocker. I think we all know who that is. Basically, it was like the first ransomware to really come out and start attacking like your attached and network storage devices. So beyond just the main endpoint, using like a 2048-bit encrypted processing schema. And it's also basically what every single crypto infection nowadays is called. So we kind of started to see it in the late 2013, around September, mainly through the Game Over Zeus botnet. The thing about that was that it was mainly using domain-generated algorithms. So it would produce thousands of these domains at once and only actually register one of them as the C2, mainly to give people like researchers and analysts a pain in the ass time to try and knock it offline. And then it's kind of really hard to see this, but the common schema of what a domain looked like is just like a bunch of random characters slammed together, making a domain. And of course, the bad part of .ru here that's kind of hard to see on the screen. It pretty much says it's bad anyway. So around mid-2014, we saw the takedown of the Game Over Zeus botnet. Basically took Cryptolocker with it. But right around the same time, we started to see a bunch of new variants emerge. Starting with like Torrent Locker, which we mainly saw in the Australian and New Zealand and some parts of European areas. It was mainly sent in the form of a fish that looked like either you had gotten a red light ticket, and they have some name for red light tickets down in Australia that I don't remember the name of, but it's not red light tickets, and or like a fake tax notice. And the screen, usually you would get redirected to a page that kind of looked like this, where it's like an official state of revenue tax notice, like a CAPTCHA that you have to go through to make sure it's not some automated process. And most of the naming conventions for the Torrent Locker, at least at the time when we were really looking into it, all kind of had like an Oz, New South Wales / post or gov, and then whatever TLD at the end of it. And they basically set out a ton of domains that look like this. So like database-nsw-gov.org or some type of like one-off that looked kind of legitimate. But the cool thing was that they used the exact same naming schema every single time. So all we had to do was kind of go through and block every single TLD that had that naming schema behind it, and it would knock it offline pretty easy. One of the other ones we started to see was Alpha Crypt or Tesla Crypt. It's basically the exact same thing, just revisioned. It kind of started out attacking video game extensions, so going after gamers basically, but they converted it over and started using like DGA-based domains. Once again, sorry, really hard to see. But it's basically just a bunch of letters and numbers slammed together to make a domain. And then they would register like one or two of them out of the thousands that were produced. So any type of lexical analysis on the domain should have been able to like spot this in your network really easily if you're doing any, looking into that type of stuff, which hopefully you are. They kind of changed this up in the later versions to make it a little bit harder using compromised domains, much like all the other ransomware variants started to do. The thing about the first round of Tesla Crypt was that it used like a symmetric key, which is really bad on their part. But the Talos group was able to release what was called Tesla Crypt, which is basically you could like take a file, drop it into the Tesla decrypt script, and it would be able to like reverse engineer the key back or something. So you could unlock all your files. And of course, the nefarious actors read the blog about how to decrypt all this stuff, so they went and they fixed that in the 2.0 version. So now we start getting into our friend Cryptowall, actually, and this is kind of where a lot of this talk centers around. Cryptowall kind of came out swinging there at the end of 2014. So instead of like using all the normal DGAs and everything else, it used a compilation of like compromised servers. Started to actually, instead of exploiting stuff itself, we would see it used through like, it would be like an exploit kit and then the binary and all that stuff. So they kind of changed up how Cryptolocker originally infected stuff. And then we also saw the implementation of like Tor and I2P being used to kind of cover the proxy tracks, which I didn't want to get in a battle with Tor. So kind of what you see, this kind of shows up at least. Your common compromise kind of happens either through the use of a phish or an exploit kit. So either someone clicks on the phish and follows the link, so they land on a page that's been compromised with either injected code or there's some like malicious ads that are running. Exploit kit happens. And then the next procedure that happens is a call out to a raw location IP address return, which basically just goes, you're like, hey, where am I? And then the domain goes, you're at 1.2.3.4 or whatever. And then after it figures out where it's at, there's a request sent to any one of numerous compromised web servers that act as a proxy in between the Tor C2s. So it basically just fires off rapidly, like domain 1, 2, 3, in a list that it has hard-coded basically into it to send the key and do all the key transfer and exchange with the main hidden C2 services. And an example of what you might see in your logs, actually, if you would happen to notice one of these ransomware infections, would be you would see this top domain here, which is actually like the Angler exploit kit. And then pretty much immediately right after that, you see this call to IP-address, which is the raw IP return domain. And there's a lot of these domains that do this. And then immediately after that, all these next 4 domains are all compromised proxies for the C2 setup. So it's kind of easy to see, like the times are super rapid fire. Sorry. And then, so the main thing that we're looking for here is this guy. So one of the reasons that they put this in here, there's actually a few of them. So one of it's the geolocation. So basically to figure out where the compromised endpoint is. One of the reasons that they do this is there's a set of countries that it doesn't react in, mainly Eastern European, Iran, or any of your APT common countries that you hear about. It won't activate in any of those countries. So, Ukraine, Russia, China, whatever. So they would also it might change the code as well. So depending on what the original exploit kit was doing, like you might hit like Angler, but instead it might give you like BDEP instead and just do some click fraud stuff. So one of the other things that it would do originally was to return the ransomware message in the native language of the country that you were in. So if you were in America, the message would be English. If you were in Spain, the message would be, in Spanish, French, etc. So it was this really nice feature that the authors had kind of built into the system. Really nice people. This part's going to be really hard to see. Sorry. So the other thing that it's used for is a unique identifier. So when the request goes out to the C2s, there's a string, and it's basically like a request ID, either like a campaign ID or an affiliate ID, an MD5 of the system for the computer, OS information, and then at the very end is the IP address. So they can kind of do this for another couple of reasons. One is to only allow one infection per system, and then it also makes it so people like researchers and analysts have a harder time seeing exactly what's going on. But at the same time, it's kind of a gold mine, because what you can do is you can use like open source tools like malware.com. And actually before, is there anyone from Shadow Server or malware? Okay, good. So, sorry. So you can use malware to do search and submit stuff. So you can basically give it like a query string like domain, IP address, and it will, return results for you. One of the bad things about malware is it doesn't really have a usable API that you can use, like to actually do stuff quickly. So what we had kind of done was put our intern on this project of making our own API for malware, so it could query, do like a bunch of search and submit stuff really, really fast, which probably breaks the toss or something, but whatever. So what you get back after you do this search is a bunch of file hashes that have all been submitted to malware that have that one artifact in it of the raw IP call out to it. So like up here we have the, our search term or whatever, and then you get all of your AV results that are basically taken from virustotal. And as you can see, like it's kind of hard to see, but if you look at the file names, they're all really super close, like pretty much obviously the exact same thing, but they all have a different MD5, and the scores from virustotal are all different. So you don't really get the most consistent results back from the AV engines like that. So if we go and we look and we just take like one of the random hashes, this is kind of snipped out from the page because there's a lot of information. But so in the artifacts here in the domains, we have our IP address raw callout. And then right after that, we have a bunch of other hard-coded domains into it, which are all basically signaling to us that they're the proxies for the ransomware binary. So I did this for probably about a month manually, going through like every hour, typing that in and searching to find brand new domains. Obviously, it gets real tedious and it's not really efficient, especially in like a big scale situation. So what we started to do, and for some reason, half of my slide isn't there, but for some reason, or whatever, sorry. So using virustotal, and then there's also another thing, and I have no idea why this part of the thing isn't there, but so there's virustotal and virustotal intelligence. So if you're lucky enough to have virustotal intelligence, it gives you the back end with a really awesome API that allows you to do a lot of really searchable stuff. One of the things it allows you to do is use Yara rules to hunt for basically anything you want. So what we decided to do was set up a bunch of Yara rules in VirusTotal, basically looking for these raw IP callouts. So in here, there's 4 of them. There's like IP-address, curl my IP, my external IP, and IP info. All 4 of these are used by various ransomware families to figure out where they're at. But a lot of them are like things like Torrent Locker will use my external IP, which is a really noisy, legitimate service that things like NVIDIA and Google and Facebook and everything else use. So if you're really trying to just find that, you get like a bunch of excess white noise, and it's really hard to figure out where the bad stuff is. But luckily, the nefarious actors decided to use IP-address, which almost no one uses. So it makes things stick out a little bit more, as we'll see here in a minute. This is kind of an example of what you get back if you have those Yara rules set up. So just by knowing what rule hit, we can tell like the first one's alpha, Tesla, Cryptowall, alpha, Tesla, Cryptowall. It's pretty easy to identify, put attribution to the sample. So if we take this one, we can take a quick look, and it's kind of the same thing that malware had. There's our raw domain call, and then some more malicious domains that are kind of hard to see, but they're there. So basically, we were like, this works really well, but it's really slow, and we're relying on other people to submit the sample. So obviously, we went a little bit bigger. And a couple of the things that we look at, especially at OpenDNS, are two things. Like one of them is called a co-recurrence, and the other one is a related domain. The sub-bullet points here, basically. A co-recurrence is basically an endpoint that requests 2 or more domains in a short time. And by like short time, we're talking like milliseconds. So like if you land on Google and all that analytic stuff that happens at the exact same time is basically a co-recurrence because it's like a batch. And then you have related domains where there's like a little bit more of a delay in the call, so it's more like a one-on-one type of thing. So what we did was looking at, this is an internal picture from our Investigate tool that we have. As you can see, kind of, down here there's like a co-recurrence, and then down over here there's a related domain section. So this was kind of our gold mine of treasure trove here. We could use the IP address to pivot. And then, I already went through that. Thanks, really. Okay. So basically, zooming in here, you can see this curl my IP and my external IP. So that means, like, basically in a sample, it had IP address, myexternal.com, and curl my IP or whatever as backups in case they couldn't reach IP address. And I should kind of back up for a second. We originally, like, my first thing was I tried to block all of these raw IP calls to see if it actually stopped the infection, and I discovered that it doesn't. So, but it was a valiant effort on my part. But once we, so basically what we started to do is kind of look at like what was going on here. And, as you can see, there's like some legitimate domains. This is like Microsoft, a bunch of Microsoft stuff, some Google, Microsoft. So there's still some noise, so you can't just like block every domain that happens to be related to that domain. But aside from these circle things, every single other one of these domains is actually one of the Cryptowall proxies, except maybe one that I missed. But so if you could filter out all this noise, you can basically say, okay, you're bad. So basically what we did was we kind of set up a script to run that checked against what was newly seen against IP address, every X amount of time. And so the script would run and be all like, have I seen you yet? And it's like, if I've seen you, you have a decision, move on. If I haven't seen you, send out a notification to one of the analysts to kind of take like a bigger, more deep dive look into it. And then one of the analysts would determine if it was bad or not, just to kind of help knock out the false positives. If it was bad, we would block it, and then we would update the training set. So eventually, and then the cycle would, rinse and repeat every X amount of time. But eventually what it allowed us to do was build up such a training set that every time a new domain was seen related to IP address that like didn't quite hit the score, we could block it in basically real time. So as soon as, the very first instance that we would see anything related to that, minutes later we could send it off, block it. It would never be an issue, which was pretty awesome. So kind of like, this is hard to see again, but so basically these kind of relate to a couple of the domains that we had visited in a previous slide. And these these bumps and the spikes are basically like when traffic starts to pick up. So like if you look kind of halfway over here, there's like no one ever going to these websites. And then all of a sudden they start taking off. And all of these single spikes are hundreds of requests, well, tens to hundreds or whatever, of requests by infected clients who have been exploited. And then that's the request trying to call to the C2, which can no longer get through because we actually caught this stuff, way below when at the beginning, before the spikes have even happened. Yeah, so it was pretty quick response time. So basically, using this method, we were able to identify somewhere in the realm of, it was like 2,905 like different various locker-based domains. Some of the other findings that we had also come across were it would surface some of the exploit kits. So like we saw things like Angler, Neutrino, and Rig, which was a side takeaway that we didn't actually expect, but was pretty cool. And probably wondering some of the ways to prevent stuff. So pretty much the number one way that the best defense that you have is basically backups. A lot of people don't do this often or well enough, but you basically want to do backups and keep them disconnected from your network due to the ransomware mapping to all of your attached storage and everything. And then I'm adamantly all about ad block and no script. That kind of helps against your malvertising or your injected codes. Social engineering, classic. Should train your end users against phishing, and more phishing, because it happens a lot, especially with those invoice and resume attachments. And then my recommendation is you never pay the ransom. Of course, some people might say that it's cheaper to pay the ransom than to deal with all the backups. It's a personal choice. And then this kind of hard to see map was kind of a geo distribution of the 2,905 domains that we saw. So you can kind of see they're pretty much all over the place except Africa. It's the safest place to have the internet. So, questions?
The geo distribution is of what exactly?
Sorry, the geo distribution is basically just like a map of all the 2,905 compromised websites that
where their IP addresses are hosted.
Yeah, where it was backtraced to. So, you know, at the time of finding out where they were hosted. So
if people are tracking the IP addresses of the malware control sites, are the encryption malwares going to start encrypting things first before they can call home?
Wait, sorry, can you?
If I understood right, you were identifying the evil sites to keep people from connecting to, so that they didn't get infected and encrypted and all that.
Oh, so you're asking if they start encrypting before they make that call to the proxy? Well, they have to be able to export everything, like all the command structure, like so they know what system is calling. Because if they don't send that out first, then they won't be able to decrypt the computer. Which, if they can't decrypt the systems, then no one's ever going to pay the ransom, because no one will ever be able to get their stuff back. So
yeah, but if you block it in a way that you can tell the victim, hey, unblock this, or you'll never get decrypted, then that would sound like, that they may have some motivation to do that.
At this point in time, the encryption's... Oh, we're on video. I can't speak for them. Yeah. So that's going to be my get out of that question there.
Yeah, why are so many countries that they don't attack, like they say, this country, are not going to affect you this ransomware? They just now trying to make money no matter where it's coming from.
You don't want to infect your mom. Affiliate program, probably something. I haven't been able to talk to him and ask him that far into it yet. Yeah. I mean, I guess it would be like an Axis Allies type, thing. Maybe, I don't know.
Expedition 3.
Yeah.
Profitable.
Yeah, that's probably a pretty good answer. I'm looking at the guy from Belarus behind you. I'm specifically staying away from anything recently, mainly because of that camera over there. and the people who watch stuff. But a lot of the Locky stuff is all DGA based currently. So there are actually, like a lot of this DGA stuff, it all comes from like a seed. So once you reverse it and you get the seed, you can just mass block all of the domains out ahead of time, which is something that's kind of going on with Locky right now. That kind of answer your question without answering the question of those people over there.
Great name.
Yeah. It's the same Drydex people. So the Drydex campaign guys are the Locky campaign people. I saw that. There you are.
I referenced the other question. Could you do something like AES encryption with the file and then create like a header where you would attach an encrypted AES key with the ID with RSA, and then essentially like when you would be giving people the fish email, you would bundle a unique RSA public key, so that way you can start encrypting the file, or it would have to call.
You're under arrest.
Okay, yeah, so you are kind of pivoting off the other question about the pre-encryption before the call to the proxies. I think it all kind of goes back to like if you can't talk to the main C2s, then you won't, like the C2s won't be able to get the key at all.
So that way, you don't block, they can't stop you by blocking the domain first, and then after you've already encrypted everything, then you send the private key over. Or you actually communicate with the server, with the C2. And if they want to decrypt their files, then they have to allow you to communicate out. Otherwise, like, the private keys.
Why are you doing this?
I think there's some people in Eastern Europe right now who probably want to talk with you about some ideas. Yeah,